Lesson 10.4, exponential functions. So before we go into exponential functions, let's go backwards. What's a linear function? Notice the first four letters of the word linear is line. So a linear function is a straight line. And that's why we call it linear. It's a straight line. Not that many things in the world are actually very linear. They usually turn and change direction and stuff like that. But we do get a fair amount of exponential functions. And if you've ever heard the term exponential growth, it means that things really take off. It starts slow and then really starts going up fast. We could also have what we call exponential decay. And that would be, call this one decay once I put it up. And that's growth. Decay would be the opposite. Looks something like that. The classic case of growth is population. The more people you have, the more babies they have, the more babies they have, the more babies they have, and things just take off, although it doesn't actually work that way. And decay is chemical breakdown. Chemicals that are dangerous in the environment actually break down. The more of them they are, the faster they break down. So they're up here on the curve, but then the less they slow down. Nuclear decay is like that. Chemical decay is like that. Things like that. So we write it as y equals a times b to the x. These are the constants. And that's the variable up in the exponent. So how does it work? And you can do this on your calculator if you want. Make a quick t-chart. So y equals 2 to the x. If I put in negative 2, it's 1 over 2 squared. And I'll write it all out. 2 to the negative 2 is the same as 1 over 2 squared is 1/4. This would be 1/2. Anything to the 0 is 1. This would be 2. This would be 4. So when we go to graph it, at negative 2, we're here. Negative 1, we're here. At 1, you see it's starting to slope up. Then you'll see how fast it takes off. At 1, we're 2. And at 2, we're 4. Never, ever, ever does it go below the x-axis, which tells you that the range for this equation is y is greater than 0. The domain is saying, what can I put in that won't blow up my calculator? And the answer to that is everything, all reals. And that's the sign for all reals. It's a little R with an extra leg on it. Don't get too hung up on domain and range, but it's good to make you think about it. You can never get a negative out of this equation. No matter what number I put in, we'll never get a negative. So try another one. And we put in 1/2 to the negative 2. That is the same as 1 over 2 to the negative 2, which is the same as 2 to the 2, which is 4. And you may recognize the pattern. It's flipped from earlier today. So 2 and up to 4, negative 1 up to 2, 1, 1/2, 1/4, and now we have what we call decay, which we'll talk about more in the next unit. Have a lot of something and then it starts breaking away. Your car actually has exponential decay in terms of its value. Starts out and it loses a lot of value right away, and then after a while, if it's 7 years old or 8 years old or has 100,000 miles or 105,000 miles, it's still worth roughly the same. Flipping over. Having a little trouble hitting my spot today. We look at a movie which has this much. Now, the way you can tell if it's growth or decay, growth would be greater than 1. Decay would be 0 less than the number less than 1. So it's a fraction between 0 and 1. This is decay because it's between 0 and 1. So we're going to see a curve like this. And that makes sense. Movie comes out, it's very popular, a lot of people go to see it. Then after a little while, other movies are out, so people go see those instead. They don't want to see the same old movie. So, since it's a movie, it can't have negative. We'll start with 0. We'll go 1 and 2. To do this, you do need a calculator, although 0 is pretty easy. It'll be 49.9. And then the first will just be 49.9 times 0.692. So this is saying the first weekend it makes almost $50 million. Second weekend it makes $34.5 million. Third weekend it makes $23.9 million. We can start graphing these in a slightly more abbreviated fashion. Let's go with every 10 million. The first one, we get $40 million on its opening weekend. Then 1 week later, we get 34.5. And then the next weekend, we get here. And I should probably graph some more points, but we know it's going to look like this. Approach 0. I don't think it would ever get to 0. There's always somebody who would still go see the movie. So that's what the curve looks like, and that is decay. It's just what it's called when the curve slopes down. Notice that the domain, again, is all reals. There's nothing I can put in there that'll blow up my calculator. And the range, y is still greater than 0 because this will never cross this line. It just keeps going and going and going, getting closer and closer. It's called an asymptote. There's a couple of good jokes on my math wall about that. So, if you want to know how much money it made, got to keep the equation where I can see it. The first weekend, it made $49.9 million. Now, the fifth weekend's a little tricky because that would actually be put in x equals 4 because the first weekend was x equals 0. So, got to watch out for that. Second weekend would be different, and you can keep it straight somehow. So you put in to the fourth. Get $11.4 million on the fifth weekend. Just a simple example. Not much there, just plugging and chugging. So which of the following is exponential behavior and why? Here's your x. It always goes up by a constant amount, or it might not, but for the source of these problems, we might need to. And how do we get from 80 to 40? Multiply by 1/2. And always do multiplying, don't do dividing. Times 1/2, times 1/2, times 1/2, times 1/2. So you might remember before we said y equals a times b to the x. Just found the b value. B equals 1/2. The a value, you could actually just pick any pair of these numbers and plug them in. But the a value is easy since b to the 0 is 1. This whole term just kind of drops or becomes 1. The a value will always be what's across from 0. So the equation is y equals 80 times 1/2 to the x. And we can see that should be decay. And it is decay. It's getting smaller, 80, 40, 20, 10, 5, 2.5. This one's getting bigger, so it might be growth, but we got to check, see if it's actually going up. And take a second, see if you can figure out what it's getting multiplied by every time. This one might be confusing, but these over here should be pretty obvious. It's times 3 every time. And if you look at these, it's also times 3. So that's my b value, b equals 3. My a value, like I said earlier, is right across from the 0. So the equation is y equals 1 times, you really don't need that, 3 to the x. And that would be growth, because that number is greater than 1. And let's look at the last one, see what we got here. This goes up, this goes up. Okay, looks like growth. Got to be careful. Are we multiplying or adding? Well, in this case, we're adding. So this is a linear function. And if you want, you can plot it, and that'll tell you it definitely is. For now, I want to take my word for it. So this is an introductory lesson into exponential stuff. Just know that you got growth, takes off, decay, drops down. That's about it. Good luck doing problems.